Thanks. And as you can see, it's an extremely broad context. Sustainable development encompasses quite a bit of things. I'll start by reminding you of something you basically know, but you don't keep in mind every day, I'm sure. And that is what we know as the Great Acceleration. And it's captured in these 24 frames. The 12 on the left are socioeconomic developments. Each frame has a time span from 1750 to the present, and the little red number giving 1950 gives you an orientation where we are. The 12 frames on the right are Earth systems trends. And for example, you have carbon dioxide, nitrous oxide, methane. Over here you have world population, real GDP, and so forth. But the common theme here is that all of these curves go dramatically upwards from about 1950 on. And this has been called the Great Acceleration because it has changed the world dramatically in all these forms and fashion. But it's also started to make us look at the planetary boundaries. Can this continue? And if so, what do we need to do about it? Planetary boundaries, you can see, include things like climate change. I suppose this doesn't show up. Atmospheric aerosol loading, ocean acidification, biochemical flows, etc. And the red, those that reach out in the red are beyond the zone of uncertainties. Those are in the green are more or less okay as far as we know. But the interesting point from the energy perspective is that several of these are closely linked to how you make energy and provide energy services. Not the least climate change, but also atmospheric aerosols, indirectly ocean acidification, and others are more or less strongly linked to how we develop energy systems. So if you then start looking at what are the demands we need to put on energy systems to make the world work, you can look at the Sustainable Development Goals that the UN General Assembly adopted in the fall of 2015. And you can see more clearly that energy comes in to many of them. Goal number 1, for example, is poverty. Number 2 is food supply, food security. Clearly they have energy requirements. Number 7 is an energy goal which deals with access to modern forms of energy, efficiency, renewables, new technologies for fossil fuels, etc. And you have urbanization here, sustainable cities, you have life on Earth, life on land, and life in water. You have number 13 as climate change. And all of these are adopted, and they serve as guidance for UN member states and activities on how to develop in the future. This builds on the very positive experience from the Millennium Development Goals adopted in year 2000. So now we will see what this means and how this can help out for the future. Looking to specific requirements on energy, these are some of the things that come to mind. Energy systems has to develop in such a way that energy services are provided for growing populations. The projection is 7 to 9+ billion by 2050, and growing economies. 2% per capita per year has been the traditional growth rate, and let's assume that continues. That would certainly be in line with desires of most governments and most communities around the world. We need universal access to modern forms of energy. That is sort of more or less a firm requirement for any meaningful development to take place. And this affects the 3 billion people without access to clean cooking. Imagine 3 billion out of the 7+ we have today, and about 1 billion people with no access to electricity. We have a requirement of affordability of energy services, and at high oil prices and even at low oil prices, that remains an issue. Security of supply was the big driver of energy discussions in the 70s, and it still applies to nations, to households, etc. And we have the added concept of peak oil that has come into this situation. Although not so intensively discussed right these days, it's underlying a lot of what is going on. We have the health and environment challenges. Acidification was an early one. Urban air pollution and other pollution effects are clearly very strong. The air pollution from cooking on inefficient stoves and badly ventilated spaces is, for example, estimated to lead to millions of excess deaths per year, mostly women and children. And to fix it is, of course, an energy issue. We have the planetary boundaries, the climate change being number one of those. And as you know, after the Paris Agreement, governments have said that we need to stay below 2 degrees warming above pre-industrial levels and as close as possible to 1.5. Now, 2 degrees means that greenhouse gas emissions have to be reduced by 2050 to approximately 0. And you can move back and forth a little bit in time, but it's a major change from the fossil fuel-dominated energy systems of the world today. We have the peace issues. Access to resources is a serious issue. We have the ancillary risks, for example, large accidents, hydropower dams, nuclear, etc., weapons proliferation, food prices, etc. And as you can see, on each one of these requires a change of the way we address energy issues. And the summary of this is that all of these linkages to how energy systems are designed and evolving leads to a major energy system and policy change. And these challenges must be addressed adequately. It's not enough to do a little bit at the margin. There are massive changes in many cases. Need to be done on time and need to be done simultaneously, in the sense that it's not sufficient to address air pollution in cities or emissions of carbon dioxide or access to modern forms of energy, because that only addresses part of the problem. If we want to have a sustainable future for the world, you have to look at the entire picture. So if you look at the history of world energy development, we started 100 plus years ago with a bioenergy dominated system. Then came coal, oil, natural gas, a little bit of nuclear, and a little bit of renewables. Hydro has a little bit larger than that, of course. Now, the question is then, what comes after year 2010 or so, which this picture, where this picture ends? What will it have to look like, and how can we shape it so that such an energy system development supports sustainability worldwide? In the Global Energy Assessment, which was the last major project many of us were involved in, asked the key question if there are a combination of resources and technologies for the use and supply of energy that can create energy systems to quantitatively address all the challenges simultaneously. This came out as a report, 2012. This was a large effort with over 300 authors from 5 continents. It was organized IPCC style with 25 chapters with convening lead authors and many other authors contributing. And Eric Larson was the convening lead authors for the fossil energy chapter and worked together with Bob. Frank von Hippel was responsible for the nuclear chapter, and Wim Turkenberg, that are also here, for the renewables chapter. And many others contributed. The answer to the question, main question asked, what was in short? Yes, there are many combinations of resources and technologies that meet all the challenges. And the major elements here are end-use efficiency, renewables, and carbon capture and storage. And I'll say a little bit about each of them and come back to the totality. On efficiency, about 30% of world energy is used for space conditioning. And we now know that we can build new houses and renovate old to a standard which uses less than 10% of what is the stock average today. That's a major change that has happened through better insulation, through LED lights, through heat recovery, solar gains, and so forth. And we've even seen quite a number of houses that we can call plus houses. That is, you add energy from panels on the roof, other arrangements, and you can supply energy over the year to the grid. So this is major developments. On efficiency, we're also seeing in transportation the change from internal combustion engines to electric engines, driven by electricity from batteries or fuel cells, and that also provide efficiency opportunities that are game changers. Look at renewables, we can see investments in renewable energies that have increased quite dramatically over the last 10 years. And the investment level today is about 15% of all energy system investments in the world. If you look at the power sector alone, in the US and in Europe, the renewables are responsible for something like between 70 and 90% of the total investments. So this is already a major transition that has begun to happen. Then the stock changes more slowly, of course. The third element is a picture from Eric's chapter in the Global Energy Assessment, and concerns how you build a system where the conversion of coal and or biomass, starting with gasification, capturing the carbon dioxide and putting it into storage, and the generation of clean fuels for whatever use, mostly vehicles, or electricity fit to the grid. And of course, some of the carbon dioxide goes back to the atmosphere in various forms and fashion. But as you take carbon dioxide through photosynthesis out for the biomass injections here, you can compensate for the fossil carbon dioxide or more. So this is a major way of thinking on how you do the utilization of particularly coal, but also how you use biomass to take CO2 out of the atmosphere. And Eric and Bob will talk more about these. Now, we did in the Global Energy Assessment a backcasting scenario for 2050. And this is, of course, a very normative exercise, because we say we wish the world to look like this by 2050. So that is basically what it needs to be, because these developments are normative. And the basic norm here is that we want a livable planet for everybody. And therefore, we selected objectives as formulated by various government entities, including the United Nations system and so forth, to see what is a reasonable level of ambition that most people would support. So, economic growth at historic rates, universal access, reduce air pollution to the World Health Organization guidelines, which is quite a reduction from the present. Stay below 2 degrees. This was done in 2011, so the 1.5 was not on the horizon yet as a public policy objective. So the analysis is down for the 2 degrees. Energy security, and address peak oil issues and weapons proliferation issues. So these were sort of the imagined world of 2050, and the analysis was done to see can we deliver on all of these. This was done through step analysis. You come in with the world here from the left, as defined. You make a split on 3 levels of energy efficiency, high efficiency, low efficiency, and one in the middle. Each of these levels is split in 2, conventional transport and advanced transport. And to the far right, you have 10 different circles, some are not filled in, where different supply combinations have been tried. Several constraints on supply has been included, like, for example, doing this without CCS, doing it without nuclear, doing without large bioenergy contributions, etc., etc. So those 10 were tried. And if you see a filled-in circle, there is such a constraint doesn't mean you cannot do it. So it means that the top rectangle, where there are only 2 circles, means that it's quite difficult with low energy efficiency systems and conventional transport to do it. But it can be done. So let's have a look at what such a system looks like. This is the one I showed you before, and we continue that to the right, and it looks like this. And you can see the bioenergy systems from the present will grow and have a little bit of bio-CCS. Conventional coal is phased out, but coal with CCS is a major contribution. Oil is declining rapidly. Gas without CCS is more or less constant, but with CCS, it grows. Nuclear, in this case, has a declining contribution. Here you have renewables, hydropower essentially, a small increase, and then you have wind and solar being the large increases in this case. So this is an example of how you can put together resources and technologies and make it work. In this work, analysis, we discussed the concept of multiple benefits and found it very useful. Because as you meet the requirements in each one of the areas I listed, you generate values and benefits for societies and for the world. These benefits and values are most often not reflected in standard economic thinking and standard economic policy making, and therefore they fall outside the driving forces in the most markets. But the inclusion of multiple benefits offers an option to convert the discussions from long-term and global benefits, which is what you talk about, reducing greenhouse gas emissions by the middle of the century and so forth, which is long-term and global, to a discussion of near-term and local benefits like jobs, here and now, health, local air pollution, etc. That is politically a very important difference. And you can even enable a discussion to shift from the burden sharing, which has been so popular and destructive, to a discussion of benefit sharing. How do you do these things in a more integrated and broad fashion? And in fact, this is changing from discussing one goal at a time, which is popular in modern societies, to discuss what you can do in various areas of action to satisfy objectives in many different dimensions. And energy is such an area of action. And that enables the generation and building up of partnerships between the many groups that then benefit from the main elements of the energy future strategies we talked about, renewables, efficiency, CCS. And this could change quite a bit of the political landscape. So some key findings. Energy systems can be transformed to support sustainable future. It requires immediate action. Energy efficiency is very effective options, which so are renewables, and exist lots of technologies for these, increasingly cost effective in the conventional sense, not including the multiple benefits. Major changes in fossil energy systems can also be envisioned. They are needed, and CCS is part of that. Nuclear energy is an option, but not a must. Universal access by 2030 is possible. Integrated energy systems are essential, and multiple benefits brings very nice benefits for all of society. And policies, regulations, and sustainable investments regimes will be essential. I haven't touched much upon that. Some of it will be done in the panel this afternoon, but I think it's sufficient to say that the PERPA experience that Eric told about illustrates that markets will not deliver on their own. And that remains true today, and we are not seeing sufficient action in that sense. Now, if we look back at this, I came into this by an invitation to come to Princeton in the spring of 1980 that Frank van Hippel gave me. And while in Princeton, it turned out that José Goldenberg and Amulya Reddy were also here. So one of the outcomes of that was the creation of this group of people. And you can recognize two of them, but this is Goldenberg and this is Amulya Reddy. And we worked intensively together, And the first book was the one Eric showed. And based on the analysis in this book, we then did a series of other things, like input to the Rio conference, like the Rio +5, like the China Council on International Cooperation, like the World Energy Assessment and Global Energy Assessment. And it's all the basic thinking coming out of this work that we did in the 80s. And José sent a letter for this occasion, and I made some excerpts from that letter of José's. And he talks about the need to avoid a disastrous future related to energy and development, and to redirect growth using technological leapfrogging in the development process, and thereby avoiding to make all the mistakes that the industrial countries made in the past. And secondly, he points at the adoption of renewables instead of fossils, and he says this is particularly useful for developing countries that have abundant such resources where they are located. And he also points to the necessity of having policy making, and he was early in acting for the introduction of carbon taxes, and he proposed that as a minister in the Brazilian government leading up to the Rio conference, now 27 years ago, and are still not adopted in most countries. Amulya is unfortunately not with us any longer, but thinking about Amulya's engagement in these issues, I'm sure he would be extremely pleased to see that things are happening increasingly fast, but not sufficient in relation to his and all of us ambitions. So Amulya would join in the congratulations to Bob at this occasion. Thank you. How energy is stored?
Energy storage.
Well, basically, you can store energy in ways we've known for very long times. What is going to be characteristic for energy, I think, is that you use very many different ways, and you combine them into systems. And many of those are emerging and go under the name of smart grids, but there are also things that are happening. And Bob's talk this afternoon will be on one of the interesting aspects of this, how you combine CCS and the generation of storable fuels. But otherwise you have hydropower storage, you have bioenergy storage, just leave the trees in the forest for a while if that is the route you have been taking, and so forth and so forth. That's not one solution, there are many. And the combination of them is what is the key.
Could you comment on the question of the use of biomass, which you forecast to be a very large contribution, and the conversion of planet Earth into a monoculture of corn, something like that? That seems to be going on. Could you tell us what your assessment is?
I would say that such a development of bioenergy would be very, very undesirable, because any bioenergy development that is that should happen has to be within very strict sustainability limits, and that kind of a corn future is certainly outside such dimensions. I would think that we have a reasonably sound approach to these things in Sweden. We have quite a lot of bioenergy. It now makes up more than 1/3 of the total primary energy in Sweden. It is mostly residues from the forest industries. There's some agricultural waste. There's almost no plantation energy. And we can see lots of unused bio streams that can be tapped. For example, biogas. We can use more of the forest wastes. And we're not even harvesting the annual growth in the forests. If you take that approach and look around the world, where could that kind of thinking be applied? In the global energy assessment, we spent a lot of effort and attention to those questions, and we had one of José's Brazilian colleagues was responsible for a chapter on how this can be developing in the world. And it turns out that there are large opportunities to do this in not all, but most countries. This is, of course, meeting violent opposition from the fossil interests. And we can see how fossil money is behind studies that attack bioenergy developments. So this is just the way it is. So be aware.